In this video, we're going to start with scientific notation, and we're eventually going to get to converting metric to metric conversions. Once again, I'm going to do all the odd problems. I'm going to leave the even ones for you to do. If you need to pause the video or go back to this video at any point during your assignment, feel free to go back through the video. I know I'm going to do all of these in one setting, but sometimes you might need to just pause it after I've done 3 or 4, and then you work on the 3 or 4 questions that correspond with the ones that I did. So to start with, we're going to convert the scientific notation to standard form, and there's a couple things that we need to remember. If we see a positive exponent, that's going to move the decimal to the right, and if we see a negative exponent, that's going to move the decimal to the left. So this is when I'm starting with scientific notation, and I'm converting the standard form. So with the very first problem, I'm going to zoom in just a little bit here. All right, I have 3.4 times 10 to the 5th. So my exponent on my 10 is 5, so that means I'm going to move 5 times to the right, right? And what I'm talking about I'm going to move is the decimal. So I start with 3.4, and I want to count 1, 2, 3, 4, 5. I'm going to move that decimal to here, and I need to go back and add zeros in for each one of those. So my solution for this one would be 3, 4, with 1, 2, 3, 4 zeros. And if I had to put a comma to separate the thousands place, I have 34,000. So I'm not going to do any of these on the calculator other than this one example. I could punch this in the calculator, 3.4 times 10 raised to the 5th power, and you'll see that I'll get 34,000 just as I did when I just simply moved the decimal. So once again, all we're doing is moving the decimal. This is scientific notation. I'm going to jump down to the odd one here, number 3. So I have 3 times 10 to the 4th. This is a very common issue where I'm dealing with a whole number here and not a decimal. So where does the decimal go? The decimal is actually understood to be behind the value. So that 3 is the same thing as 3.0. So now I need to grab that decimal and move it 4 times to the right. And then I'm going to go back in and add zeros. So that would give me the value 30,000. Number 5, here I'm starting with the decimal 0.0042. I have 10 to the 5th, so that means I need to move it 5 times to the right. 1, 2, 3, 4, 5. My new decimal's here, and so what I'm left with is 0.00420 with a decimal. It's very uncommon to see zeros in front of your whole number, so let's go ahead and eliminate those. So I have 420 as my solution here. So once again, I'm just grabbing the decimal, moving it to the right, and I might have to add zeros. In this last case, I needed to get rid of those zeros in front because we usually don't keep zeros in front of a value as long as they're not behind the decimal place. Number 7, this will be the first one that you'll see that I'm moving in the opposite direction. Here I have 10 to the negative 5, so I'm starting with the value 1.4, and since it's negative, I want to move left 5 times, so I grab the decimal, 1, 2, 3, 4, 5. My decimal goes right here, and then I have zeros that I needed to hold that place. So my answer is 0.00014. You can leave it like that for my class. Some instructors will want you to put a 0 in front of that decimal place just to kind of highlight that, hey, everything else is behind the decimal. Let me move to number 9. So I have 2 times 10 to the negative 4th. Once again, if we do not see a decimal, it's understood to be behind the value. And if I'm moving this to the negative 4th, I move it 4 times to the left. 2, 3, 4. My decimal's here. I have to come back in and add those zeros. So I have 0.0002. Once again, if you want to put 1 0 in front of that, you can. Number 11, I have 0.0012, and I'm going to move that 5 times to the left once again. So 1, 2, 3, 4, 5. So this case, I'm going to have a lot of zeros behind my decimal. If I can count 1, 2, 3, 4, 5, 6, 7. And I probably shouldn't have struck through them because I don't want to delete them. I was just counting them. But 1, 2, 3, 4, 5, 6, 7. So I have 7 zeros and then the 1, 2. And since those are behind the decimal, I cannot get rid of those. Those are very important. Unlike the one way over here that my zeros were in front of the decimal, right? And in front of all the numbers, they were unnecessary. But zeros behind the decimal, I need to make sure that I keep. Those are important. All right, and number 13, I have 0.4 times 10 to the third. Now this is a case where I'm starting with 0.4, and that's understood to be 0.4, but 10 to the 3, and I might have said 13, but 10 to the 3 just means I move it 3 times to the right. So once again, this was positive, so I was going to move this one to the right. So if I move it to the right, I have 0, 4, 0, 0, and then the decimal. So once again, that one would just be written as 400. There's no point in writing the 0 in front, and there's also no point in writing the decimal. Number 15, 10 to the 4 means move it 4 times to the right. So 1, 2, 3, 4. That gives me 1, 3, 3, 3, 4.3. And if you want to add a comma to separate your thousands place, you can do that. But the comma is not necessary either. All right, so that was me doing the odd ones, 1 through 15. You're going to have the even ones to do in that section. I'm going to move on. Now, this is a less common practice, but we could start with a standard notation and convert to scientific notation. So once again, we're just going to count how many places do we need to move the decimal where we have one digit or one value in front of the decimal place. So with this one, I'm going to zoom in just a little bit more for these. Okay, so for number 17, I'm going to work in blue this time to kind of distinguish what I'm doing. So my decimal would be here. All right, and I want to move this to this location here. I want one value, so this is one digit. I want one digit in front of the decimal place. So I want this to have a ones place in front. So how many times do I have to move? I move 1, 2, 3. So I need to move 3. So I have 3.548 times 10, and then I moved 3 times to the left. Since I started here, this was the start, and I ended here, right? That's where I wanted to end. I had to go to the left, so I have 3 times to the left. This one is a little bit opposite of how we think. This time when I had to move to the left, I want to make sure that I have a positive 3 here. And if we work this backwards, and here's how I think it's the easiest way to describe it. If I started in scientific notation, this 10 to the third would say move 3 times to the right. So if I move this 3 times to the right, you would see that I have the value 3, 5, 4, 8. So that's how I think of it. Is sometimes I double check myself by working backwards. For some reason, my mind works better going from scientific notation to standard notation. And in this case, we're just taking standard notation and going to scientific notation. So let's look at number 19. My decimal starts here. I need to move it 2 times to the left. If I do that, I have 3.17875. And I moved it 2 times to the left. So here I think opposite. That's going to be a positive 2. If I work backwards, right? So if I just had 3.17875 times 10 squared, I would move this 2 times to the right, and you would see that I would end up with that value there. So that's how I double check myself at least. With this one, I can see that I have zeros. The first digit I have is 4, so I want to move my decimal place here. How do I get there? 1, 2, 3 times to the right. So I have 4.65, and I'm going to multiply that by 10 to the negative 3. Once again, if you work backwards, you should be able to double check yourself and make sure that you at least get back to where we started at, not where we were after we moved it. 23, I need my decimal place here, right here. So how do I get there? I move it 1 time to the left. So now I have the value 1.92843. And I move that 1 time to the left. So I'm going to have 10 to the 1, or just times 10. That's the same thing as 10 to the 1. 25 is a slightly tricky one. And 25 corresponds with your 24. But 25, I have 5.1234. So if we look at this, I only have one digit in front of the decimal. So I don't need to do anything to this. This is just 5.1234 times 10 to the 0. And 10 to the 0 is the same thing as 1. And if you don't believe me, you can check that in your calculator. It seems unique, but 10 to the 0 is just 1. So if I multiply this times 1, I'm just left with 5.1234. So this one's kind of tricky, corresponds with your number 24. We don't need to do anything because we already had one digit in front of our decimal. So it's already in scientific notation. We just don't have to write the times 10 to the 0. All right, I'm going to move on. This we're going to deal with metric to metric conversions. Sorry, I already had some stuff here. I was testing it out. Okay, so I'm going to provide you this this conversion sheet here. All right, I'm going to get to that a little bit later, but we need to know a couple things before I talk about it. We have base units, which are going to be grams, meters, and liters. And the good thing about the metric system is it uses the same prefix to talk about each one of these. So grams would be weight, meters would be a length, and liters would be like a volume, so a three-dimensional space. So some people have heard of a saying, King Henry died Monday drinking chocolate milk. That kind of corresponds with this metric line right here. I'm going to use that for the first few examples, and then I'm going to show us a more mathematical approach. So let's start with this, and this corresponds with everything we see up here. I just don't include all of it. I start here, King Henry died Monday drinking chocolate milk, right? So that's my kilo, hecto, deca. My unit is either going to be gram, meter, or liters, and then deci, centi, milli, or over here. So with this one, all we're doing is moving decimal places, and we're going to move those along this corresponding line. So let's erase all of this. All right, so if I am starting with 12 kilometers, I'm starting here. Let me grab the black. I'm starting here, and I want to go to decimeters. So I want to go to decimeters. How many times do I have to move to get there? 1, 2, 3, 4. So all I'm doing is grabbing the value 12, which I started with. I start with my decimal, and I need to move. I move to the right. Right. I started on the left. I moved to the right. So I need to move that decimal 4 times to the right. Very similar to what we were doing with scientific notation. And add back in your zeros, and that would give you 1, 2, 0, 0, 0, 0, which would be 120,000, and that would be decimeters. All right, once again, I'm going to leave the odd ones for y'all to do. So if I go to 28, 1.2 millimeters to decimeters. So I'm going to erase where I was, and hopefully my eraser erases it all this time. All right, so with number 28, I'm starting at millimeters. So I'm starting here at milli. And I want to go to decimeters, 2 times to the left. So I just need to grab the value, 1.2, and go 2 times to the left. So I'm here. So now I have, to fill in that zeros, I have 0.012, sorry. I can always add 1 0 in front of the decimal, but my final answer is in decimeters. So I have decimeters. And one thing that I'm doing here that I do want you to be cautious about, because you won't always see it this way, is I'm giving you the non-abbreviated version, but most of the time you will see it in the abbreviated version as I have in my parentheses here. So get used to the abbreviations, because that can be part of the biggest challenge of knowing, okay, where am I at? Am I at decimeters or decameters? So get used to the abbreviations. They should be all listed right here also. Okay, so those would just be moving along. Essentially, I'm going to call it the metric line. But now I'm going to look at a more mathematical approach to what we just did. You'll notice that I have the same thing. All right, the ones we just dealt with were kilo, hecto, deca, milli, centi, and deci, along with the base unit. But here, let's look at how we can do this more mathematically. So we already did number 30. I just did it along the number line. So I moved from kilometer to decimeter. And if we looked at that again, so I'm going to try to go back to it. If we looked at this again, I moved from kilometer to decimeter. So I moved 1, 2, 3, 4 times. I moved 4 times to the right. That's how I got there. And I added 4 zeros. So mathematically, how could we come up with the same thing without having to count that number line? And that's where this table right here is going to come into play. So if I'm going from kilo, which is here, and you'll see this value, this is represented by 10 to the third, and I want to go to deci, which deci is the d by itself, not deca, right? So deci is the d by itself. This is 10 to the 1. How do I figure out how many times did I move? So what you want to do is you want to grab your exponent, 3, and figure out how many times you have to go to get to negative 1. The way that you would do that mathematically, the distance between things we always subtract. 3 minus a negative 1, if you subtract a negative, that's the same thing as adding. So 3 plus 1 gives me 4. And don't be afraid to use your calculator for this. 3 minus, and here's how you type in a negative. I always like to put my negatives in parentheses. You don't have to, in this case at least. So 3 minus a negative 1 gives me 4. So this tells me 4, and since it's positive, right, this was a positive 4, not a negative 4. Positive means move to the right. So essentially, we're right back into moving that decimal place. I start with 12. My decimal's here, and I need to move it 4 times to the right. So I have 1, 2, 0, 0, 0, 0. I have 120,000 decimeters, just like I got the first time. And I apologize for my handwriting there, but that's the same answer that I got when I did it moving it by hand. All right, here I'm just taking the mathematical approach, and I'm also using this form of scientific notation, right, this form of 10 raised to some exponent to get there. And all I'm doing is counting how many times I move. And once we have this, now we can use these other prefixes that didn't show up on my little chart that I had up here, right? My chart up here was limited to only those prefixes. So let's do a couple more. I'll let y'all do 31. Let me erase all of this. Okay, so with number 32, I'm going from millimeters to decimeters. So I need to figure out what were those values. So millimeters is here, 10 to the negative 3, and decimeters is here, 10 to the negative 1. So I have 10 to the negative 3, and I want to go to 10 to the negative 1. Now, the direction you're moving in is very important. I always start with 1 and go to other. So how do I go from negative 3 to 1? I start with negative 3, and I always subtract the second value, which is negative 1. And once again, go to your calculator if you need to on this. So sometimes working with negatives can be a little tricky. I have negative 3 minus negative 1, and that should give me negative 2. Negative 2. So what is that telling me to do? Negative 2 tells me to move the decimal 2 times left. So I start with 12.58. Probably need to zoom in a little. And if I move that decimal 2 times to the left, now I'm at 0.1258. I can always add a 0 in front, and now I'm in decimeters. All right, so let's check out 34. Here I'm dealing with nanometers, so what I'm going to do is I'm going to grab that prefix for nanometers, which is 10 to the negative 9th, 10 to the negative 9th, and I want to go to kilometers, which is 10 to the 3rd. I'm going to have a big difference here. So I started with 10 to the negative 9th, and I want to go to 10 to the 3rd, so how do I get there? I'd say negative 9 minus 3. You can type that in your calculator, but that would give you negative 12, so that means move 12 times left. And what am I moving 12 times left? I'm moving the decimal. So I have my 125.34, and I need to move this 12 times to the left. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. My decimal is going to go here, and I need to add back zeros into all of this. See if I can grab my smaller pen. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to have 9 zeros. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros, and then the 1, 2, 5, 3, 4, and that would be how many kilometers I have. So minor mistake there. I looked at this instead of my word, and I realized I had a typo. This is a kilometer, so that's what I just did. You may have saw that in the video before I got there, but I converted nanometers to kilometers there. Kilometers was 10 to the third, nanometers was 10 to the -9. Let me double check that just in case. Kilometers 10 to the third, nanometers 10 to the -9. Yep, sorry for the typo in my wording. My prefix didn't match my acronym didn't match my word. All right, but y'all would want to do the same thing with number 35. We're going from gigagrams, which is GG, to decagrams, which is DAG. Perfect. And that's going to be it for this video. So I've done all the even ones. Your job for this assignment is to do the odd ones and submit it back to Moodle.